So number 2 on the related rates quiz was definitely the hard one. Some people got close, but no one really completely got it, which makes sense. I don't think we've done one exactly like this, so I want to go over it and then give you guys another chance. Okay, so here's the deal. The sun is rising at 2 degrees per minute. Right away, you know, wait, degrees, they're kind of a random unit. We're going to have to change that to radians. So we know we're going to have to do that work. So 2 degrees per minute, the sun is rising. So here's the person's shadow, and the shadow is obviously getting smaller, right? As the sun rises, your shadow gets smaller. So we want to know how fast the shadow is getting smaller, which means it should be a negative number when we get our answer. So I'm going to call x the length of the shadow from our 6-foot tall person to the vertex of our triangle there, and then theta, the angle. And we know that theta, so it rises 2 degrees per minute, or theta dot equals 2 degrees per minute. So theta dot is 2 degrees per minute, which of course we have to change to radians. Okay, so what we want is x dot, how fast the shadow is shortening. We want x dot when x is equal to 12. So when x is 12 feet, we want to know what x dot is. So when your shadow is 12 feet, how fast is it getting shorter? That's the idea. Okay, first we need to change 2 degrees per minute to how many radians per minute. So 2 degrees, let's just change 2 degrees to radians and then that'll work. So 2 degrees is, we multiply the 2 degrees times pi is the same as 180 degrees. So that's 2 divided by, that's pi over 90, so that's pi over 90 radians. So it's pi over 90 radians per minute. So theta dot is pi over 90 radians per minute. We don't usually need to write radians, so it's just pi over 90. We'll call it. We know that we're doing it, and I'll write radians. So radians per minute. We'll just know that we're doing everything in minutes, and since we're in radians, we know we're good, because math works naturally with radians. Okay, so that's our theta dot. So we want x dot. We know this is 6. Here's our angle. We know theta dot. So this is the opposite. This is the adjacent. X is the adjacent. Theta is 6 feet is the opposite. So tangent is opposite over adjacent. So tangent of theta is equal to the opposite, which is 6 feet, always 6, divided by the adjacent, which is x. And now we just take the derivative of this with respect to time. I'm going to make this a little bit easier. Instead of writing over x, I'm going to make that x to the negative 1. So tangent theta is equal to 6x to the negative 1, because that's easier to take the derivative of. Now we take the derivative of this whole thing with respect to time. Okay, of this whole thing. Derivative of tangent is secant squared. So secant squared theta times the derivative of what's inside. What's inside is theta, so that's times theta dot. That's this side. Equals, see, derivative of 6x to the negative 1 is negative 6. X to the negative 2, right? Just same old derivative thing. And then we go, wait, and then we have to take the derivative of x, so then we multiply by x dot. Now, we're kind of done. We want x dot. So so let's solve for x dot then. This is the same thing. It gets kind of confusing, this x to the negative 2. Let's write this as negative 6 over x squared, because x to the negative 2 means over x squared, x dot. Put the x squared, negative 6 on the other side. So I'm doing my algebra correctly here. We already had a secant squared theta dot. We're going to multiply the top by x squared. So it's x squared secant squared theta times theta dot on the top. And then we have a negative 6 in the bottom. I just put the 6 in the bottom, make it negative there. Okay, that's what x dot is. We know x is 6, x is 12. We want x dot when x equals 12. We know theta dot is pi over 90. We don't know secant squared theta. We're going to have to figure out what secant squared theta is. So I'm going to do that over here. So secant squared theta is the same. Secant is 1 over cosine, because there's a co in every partner. So that's 1 over cosine squared theta. Cosine is adjacent over hypotenuse. So 1 over that is hypotenuse over adjacent, right? Cosine upside down. Hypotenuse over the adjacent, and that's squared. So hypotenuse squared over the adjacent squared. Okay, so we look at our triangle up here. We don't know what the hypotenuse is, but we know what the adjacent is, x. So we can figure out what the hypotenuse is, because I'll do that right here. Let's call it h for hypotenuse, I guess. So h squared is 6 squared plus x squared, right? So h squared is 6 squared plus x squared, just Pythagorean theorem, which is 36 plus x squared. That's the hypotenuse squared. I can write hypotenuse there. Hypotenuse squared. Okay, I'll just call hypotenuse. What the heck? Hypotenuse squared is 6 squared plus a squared, which is 36 x squared. So we can just leave it like that. So this is equal to the top hypotenuse squared is 36 plus x squared. The adjacent is just x squared. So that's what secant squared theta is. Now we want to know what this is when x is 12. So when x is 12, this is 36 plus 12 squared divided by 12 squared. Oh, 12 squared is 144. 144 plus 36 is 180. That's 180 over 144, right? 12 squared in the bottom is 144. Yes, that's 180 over 144. So secant squared is 180 over 144. So all of this then is negative x squared. X is 12, so that's 12 squared, times secant squared, which is 180 over 144, times theta dot, which is pi over 90, divided by 6. Notice this is really nice. 12 squared is 144. That's how we got that. 144. Those cancel. 180 divided by 90 is 2. So those cancel. We have 2. So on the top we have 2 pi over 6. So that's, yep, I think I did that right. Yep. Negative 2 pi divided by 6, which is just negative pi over 3. So negative pi over 3. And that's x dot. That's how fast the shadow is changing. We're dealing with feet, so we can say feet per minute. If we want a number for that, pi is 3.14. You go pi divided by 3, and that's about 1.047. So if you want a number, negative 1.047 feet per minute. Notice negative, like we thought, the shadow is getting shorter, so the negative did come out nicely. So, yep, that's how you do it. This is definitely hard. This is like the hardest these get, the whole secant squared theta and all that kind of stuff. But it's nothing we haven't done before. You just have to be very systematic and be very careful, take a lot of room. I probably didn't give you enough room in a piece of paper, but since most of you didn't print it out anyway, you can use as much paper as you like. And by the way, 2 degrees per minute is really fast, right? That would mean to get to 90 degrees for the sun to rise, it would take 45 minutes. So on this planet, the sun rises in 45 minutes. On Earth, it's 1/4 degree per minute, 8 times longer. And that's what we would do on Earth. We'd just use 1/4 degrees per minute, which would be 8 times less than this, and then we could do it for Earth. You could figure out how fast your shadow is shortening on Earth just by using 1/4 degree instead of 2 degrees. Okay, thanks for listening. Hope that helped.